Hello, everyone. Welcome. Hi, I'm Oliver.
Hi, I'm Lily.
Welcome to Science in Easy English with Oliver and Lily.
Why are we afraid of the dark?
Have you ever found yourself reaching for the light switch just a little faster than usual after watching a scary movie?
Oh, definitely.
Right. Or maybe you felt that sudden, strange chill when walking down a dimly lit hallway in your own home, even though you know exactly what is there.
Yeah, it's such a universal feeling.
It really is. Well, today we are going on a fascinating journey, and we are thrilled to have you joining us for this deep dive. We have an incredible stack of material to go through today. I mean, we are looking at everything from evolutionary biology texts and cutting-edge neuroscience journals to psychological studies on child development.
And even some of the latest breakthroughs in virtual reality technology, which is wild.
It is. So our mission for this deep dive is to unpack the real reasons behind your fear of the dark.
Right.
We are going to explore what is physically happening in your brain when the lights go out, how this fear shifts from when you are a child to when you are an adult, and the incredible high-tech ways we are actually learning to conquer it.
It is a massive topic. You know, we often dismiss the fear of the dark as something childish, like something we're just supposed to grow out of. But when you look at the science, you realize it is a deeply ingrained, complex response that has literally kept our species alive.
Okay, so to really understand this, let's step into a time machine for a second. I want you to picture our ancient ancestors. Before we had technology, before streetlights, before even reliable fire, humans were absolutely not the apex predators we consider ourselves to be today.
Not at all.
We were incredibly vulnerable. When the sun went down, our relatively poor night vision put us at a massive disadvantage.
Yeah.
We were basically midnight snacks for nocturnal predators like large cats.
Yeah.
So being afraid of the dark wasn't some irrational phobia back then. It was the ultimate survival tool.
Exactly. And the most fascinating part of this is the concept of evolutionary preparedness.
Right.
Humans didn't just casually learn to be afraid of the dark over time through trial and error. Evolutionary processes actually hardwired this fear right into us. The idea is that fears of the dark or of snakes or of heights were such critical survival mechanisms that they are actually encoded into our DNA.
Encoded right into the DNA. That is just incredible to think about.
It is. It is a lingering, foreboding anxiety designed to keep you on your toes. Your body enters a mild state of fight or flight simply because the lights go out. It's basically a biological echo from thousands of years ago reminding you to stay alert.
That makes so much sense. And here is an analogy to make this totally relatable to what you might experience today, just sitting in your own bedroom. It isn't actually the absence of light that scares you. It is what might be lurking in it.
Oh, exactly. The unknown.
Right. Because you can't see, your brain feels vulnerable, and your imagination rushes in to fill that void. Suddenly, an empty room feels incredibly crowded.
That brings up a really specific, almost universal experience from the research. Think about a chair in the corner of your bedroom with a coat draped over it, or maybe a large teddy bear sitting on the floor.
Oh, I know where you're going with this.
Right. During the day, they are completely harmless. But in the dark, they suddenly look incredibly uncanny.
I know exactly what you mean. I have a bathrobe that hangs on the back of my bathroom door. And if I get up at 2 a.m. for a glass of water, my heart skips a beat. Because in the dark, it looks exactly like a tall person just standing there waiting for me.
Yes. And there's a very clear psychological explanation for that. Because your vision is compromised in low light, your brain subconsciously gets confused by these ambiguous shapes. Now, the human brain hates being confused.
It really does. It
Yeah.
wants patterns.
Exactly. It desperately tries to make sense of the visual data to find answers. Think of it like autocorrect on your phone, trying to fix a misspelled word. In the dark, your brain tries to autocorrect the shape of that bathrobe. And because of that ancient DNA we talked about, it defaults to a potential threat.
Better safe than sorry, basically.
Precisely. And this leads to the uncanny valley effect. That is the sudden revulsion we feel when something looks familiar, maybe even human-like, but just seemingly off. Your brain turns a pile of laundry into a creepy creature.
So if my brain is mistaking laundry for a predator, What is actually misfiring inside my head at that exact moment?
Mm.
What is physically happening when the lights go out?
It all starts with the amygdala. That is the tiny, almond-shaped alarm system deep in your brain. When it detects a potential threat like sudden darkness or a weird shadowy shape, it triggers the startle response.
So that is the physical reaction.
Right. We are talking about freezing in place, an increased heart rate, and a rush of stress hormones flooding your blood. And that physical reaction creates a forward feedback loop of hypervigilance.
What does that hypervigilance actually look like, though? Is it just feeling jumpy?
It is much more active than that. Researchers actually tested this by putting people in front of a computer screen showing vague, ambiguous scenes. They induced a hyper-vigilant mindset by telling the participants they needed to find a hidden threat on the screen, and if they failed, there would be a negative punishment, like a sudden loud noise.
Okay, so they prime them to be stressed.
Exactly. And what they found was that these participants started scanning the screen frantically. But even more interestingly, their pupils dilated significantly compared to people who weren't stressed.
Taking in more light.
Yes, gathering data. They were constantly scanning the screen, their bodies practically buzzing with adrenaline, looking at completely neutral, harmless things, and often without even realizing their anxiety was spiking.
Wow. So just the suggestion of a threat
Yeah.
puts the brain's visual system into overdrive. But it's not just a runaway train, right? There has to be a part of the brain that is supposed to hit the brakes and keep that panic in check.
There is, and this is where it gets highly delicate. A specific part of the amygdala called the basolateral amygdala, or the BLA, acts as an inhibitor. It usually suppresses our unconditioned, innate fears once we realize we are safe.
So it tells us, hey, it is just a bathrobe.
Right, and to prove how vital this is, researchers looked at individuals with a very rare genetic syndrome called Urbach-Wiethe disease. These individuals have damage to both the left and right sides of their BLA, while the rest of their brain's alarm system remains perfectly intact.
So their alarm can go off, but they don't have the brakes to stop it.
That is exactly it. The researchers used eye tracking and a test that messes with the brain's processing speed. It is like making you read the word blue when it is printed in red ink.
Oh, the Stroop test.
Yes, they found that these subjects were incredibly hypervigilant to fearful faces, which are innate threat cues for humans. Because their BLA was damaged, it couldn't inhibit that base fear response. It proves just how precise our brain's threat vigilant system is, and how easily it can tip into anxiety if the inhibitor isn't working perfectly.
Okay, here is the part of the research I found absolutely fascinating. I was reading about these specific brain cells called astrocytes. They literally look like little stars. But for the longest time, science completely dismissed them, right? They were just seen as housekeeping cells that held the neural networks together and cleaned up around the neurons.
That was the accepted belief for decades. But a recent massive breakthrough completely flips that narrative. Using fluorescent sensors in a mouse model, scientists discovered that astrocytes are not just support staff. They actively encode, maintain, and extinguish fear memories right there in the amygdala.
Wait, so they aren't just cleaning up the brain, they're actually controlling the fear itself.
Yes. The researchers found that altering these star-shaped cells physically reshapes how fear signaling travels to the prefrontal cortex, which is our decision-making center. When they disrupted the astrocyte signaling in the mice, the neurons couldn't generate their typical fear-related patterns. The mice essentially forgot to be afraid.
That is a monumental shift.
It really is. It completely changes our understanding of how fear is processed. It holds incredible implications for how we might treat PTSD and severe anxiety disorders in the future. Because we now know therapies might need to target not just the neurons, but these star-shaped astrocytes as well.
It is amazing how much complex biology is happening under the hood when we just turn off a lamp.
Hmm.
But let's bring this out of the lab and into the real world. We have this ancient alarm system, but it seems to really hit a fever pitch when we are kids. The data shows that the fear of the dark usually peaks between the ages of 2 and 6.
Right, and that makes perfect sense developmentally. This is the exact age when a child's imagination is running absolutely wild, but their brain hasn't fully developed the ability to distinguish fantasy from reality. To a 4-year-old, the monster under the bed isn't a theory, it is a factual reality.
For any of you listening who are parents, the research actually highlights some incredibly practical do's and don'ts for handling this phase. And the first one surprised me, diet.
It is huge. What your child eats directly impacts their nighttime anxiety. High sugar foods cause blood glucose spikes, which are linked to poor quality sleep and increased time lying awake.
Wait, so a sugar rush isn't just making them energetic and hyper, it is actually giving their imagination the fuel and the time in the dark to create anxiety.
Precisely. The longer they are awake in the dark, the more time their brain has to try and autocorrect shadows into monsters. Conversely, giving them snacks like almonds, which contain tryptophan and magnesium, or some chamomile tea, can actively promote muscle relaxation. It helps them fall asleep faster, basically bypassing that anxiety window.
I love that. A physical, nutritional solution to an emotional problem. But what about the psychological side of parenting through this? Because it is so easy to just get frustrated when you want them to go to sleep.
Validation is key. You should never dismiss their fear, but you also shouldn't use fear as a parenting tool. Jokingly saying something like go to sleep or the boogeyman will get you can actually instill deep, unhealthy anxieties. You also have to be very careful with co-sleeping.
Because it becomes a crutch.
Yes, while it is great to validate their fear and comfort them, constant reactive co-sleeping every single time they get scared can accidentally reinforce the idea that they cannot handle the fear alone. It can lead to long-term sleep dependency. Instead, psychologists suggest using empowering tools, for instance, the anti-monster letter.
Oh, this is such a brilliant strategy.
It really is. You and your child sit down and write a formal contract laying out strict rules for any imaginary monsters. You write things like, you can only visit on Thursdays and you must stay quiet.
That is so smart.
It sounds silly to an adult, but to a child whose fantasy is their reality, it gives them a profound sense of control and mastery over their fear.
Give them the power. But what happens when we grow up? We know the fear of the dark doesn't always magically vanish on our 18th birthday. How does this transition into adulthood?
It morphs. It transitions from an unrealistic fear like monsters in the closet to a very realistic fear. As adults, our brains start scanning the dark for victimization, crime, and physical harm.
There was a really interesting photo study published in the Psyche Journal that demonstrated this perfectly.
Yes, researchers took a group of college students and had them rate their comfort levels looking at pairs of photos. Each pair showed the same exact location, once during the day and once at night.
And unsurprisingly, the night photos were scarier.
Right, every single nighttime photo was rated as more uncomfortable. But the nuances are what matter. A well-lit nighttime gazebo was rated much more comfortable than a dark nighttime alleyway.
Because the alleyway has blind corners and shadows. It is all about threat concealment.
Exactly. It proves the adult fear is linked directly to the environment's potential for hiding a real-world threat. And there was a significant demographic finding there, too. The study found that women reported feeling significantly less comfortable than men with almost all of the nighttime photos.
That is a stark difference.
It is. The researchers suggested this demographic divide points to how adult fears transition away from the boogeyman and become anchored in a person's awareness of their real-world vulnerabilities. It becomes a highly calibrated threat assessment based on their environment.
That is a very sobering but vital point. The brain is just trying to protect you based on the realities of the world. But what happens when that threat assessment goes too far? There is a clear line between being uneasy in a dark alley and having what is called nyctophobia.
Nyctophobia is when that fear becomes extreme, irrational, and actively disrupts your daily life. We are talking about severe physical symptoms when the lights go out. Chest tightness, nausea, lightheadedness, and profound insomnia.
And lack of sleep just makes it worse, right?
Yes, studies show that poor sleepers are actually significantly more likely to startle in the dark than good sleepers. It becomes a vicious cycle. You are afraid of the dark, so you don't sleep, which makes your brain more hypervigilant, which makes you more afraid of the dark.
So how do you break that cycle?
When it reaches that phobic level, cognitive behavioral therapy, or CBT, is the gold standard. It helps patients identify and restructure their fearful thoughts. There is also exposure therapy, where a patient is gradually introduced to darker environments. Alongside this, therapists teach mindfulness and grounding techniques.
Like the 5, 4, 3, 2, 1 technique. Okay.
Exactly. That is where you identify 5 things you can see, 4 you can touch, 3 you can hear, 2 you can smell, and 1 you can taste. The reason it works is that it overloads your brain's sensory processing center with present moment data.
So it basically distracts the alarm system.
Yes, it forces your brain to focus on what is actually in the room, leaving no processing power for the amygdala's imagined threats. There are even telehealth CBT programs specifically for children that have shown incredible results in disrupting the nightmare cycle and reducing daytime anxiety using these exact methods.
But let's say traditional exposure therapy sounds totally intimidating. How do you do exposure therapy for the dark without just throwing someone in a terrifying black room? Here's where the high-tech revolution comes in. Enter virtual reality exposure therapy, or VRET, and augmented reality.
VR is an absolute game changer for treating phobias. Think about traditional exposure. Asking someone with severe nyctophobia to just go sit in a dark room can be completely overwhelming. They might just refuse to do it. But VR provides a highly immersive yet entirely safe environment.
It is like having training wheels for your phobia. You know you are physically safe in a brightly lit clinic, but your brain gets to practice facing the fear.
Precisely. And the therapist can strictly control the exact intensity of the darkness. They can start you in a dimly lit virtual room and slowly, session by session, dial down the light. Furthermore, modern VR systems integrate real-time biofeedback.
Tracking the physical response.
Right, they track your heart rate and breathing stability while you are in the headset. If your heart rate suddenly spikes, the therapist sees it instantly on their monitor and can just brighten the virtual room or guide you through breathing exercises until you calm down.
That is incredible. But of course, VR isn't perfect for everyone. What are the downsides we found in the sources?
The main drawback is cybersickness. This is a specific type of nausea caused by the visual discrepancies between what your eyes see in the headset and what your inner ear is feeling in the real world. Your brain gets confused by the mixed signals.
Makes sense.
There is also the potential for eye strain and sometimes a temporary feeling of derealization, feeling like the real world isn't quite real right after taking the headset off. But overall, the success rates are staggering. Some studies show VR and AR exposure therapies being 80 to 90% effective at treating specific phobias.
That is amazing.
It truly represents the incredible intersection of technology and psychology. We are using our most advanced visual technology to soothe one of our most ancient visual fears.
So what does this all mean for you, the listener? We have covered massive ground today. We started with our ancient ancestors huddling together, relying on their DNA-encoded fight-or-flight responses to survive the night. We zoomed way into the brain to discover how tiny, star-shaped astrocytes are actively managing our fear memories and controlling how we process threats.
We looked at the practical, nutritional, and psychological steps for helping a toddler sleep through the night without the boogeyman.
And we explored how adults transfer those childhood fears to real-world anxieties based on their environment. Finally, we looked at how putting on a high-tech VR headset might be the ultimate modern cure for nyctophobia. Whether you're trying to get your kid to stay in their own bed or you're just trying to understand your own racing heart when the power goes out, it all comes down to your brain trying its absolute best to keep you safe.
This does raise one final important question to think about, though. If we connect all of this to the bigger picture, our brains are still carrying the genetic, DNA-encoded fears of ancient predators from thousands of years ago. Our bodies still react to a dark room as if a large cat is waiting in the corner.
Right.
If our evolution casts such a long, powerful shadow, it makes you wonder what modern fears we are currently experiencing that will become permanent fixtures in the human genome. Are our chronic anxieties around constant technological connection or modern social isolation, or even the rapidly changing climate, are these the new predators that we are currently hardwiring into the DNA of the humans who will be born thousands of years from now?
That is a fascinating and honestly slightly haunting thought to end on. Thank you so much for joining us for this deep dive. We hope you walk away with a little more light to shine on the shadows. Stay curious, everyone.